Remember, last week we started learning about exponential equations. What is the form for an exponential equation? Y equals what? A times b to the x. Okay? Remember, your A was your starting value, B was your growth or decay factor, okay, and then you have the exponent. But look at the equations we're going to be using today. We have A equals P times 1 plus R raised to the T power, A equals P times 1 minus R raised to the T power, and A equals P times E raised to the R times T power. The first two look very similar. What's the only difference? Right, we have a plus and a minus. That's the only difference. That's because this one will be used for growth. Okay? Any word problem that we're doing that is growth, we'll use this equation. If it's decay, we'll use the one with the minus. Now, both of those equations are actually, all of them are exponential equations. Let me show you how similar they really are to this equation that we learned last week. A equals, it's just in the place of y, P in place of the A. In place of the B, you're either going to do 1 plus R or 1 minus R. And in place of the X, T for time. Now, we're using T for time because we're doing word problems. Okay? We want to find out how much money's there after X amount of years or T amount of years. R for rate. Okay? Your money is either going to, or whatever you're dealing with, is either going to increase or decrease by a rate. So that's why instead of just B, we have to use 1 plus R or 1 minus R. But don't you see how those are very similar? Okay, you have inherited a diamond tennis bracelet from your mom on your wedding day with an appraised value of $9,875. The appraised value has increased 3% each year. Is this a growth or a decay? Growth. So we're going to be using A equals P times 1 plus R to the T power. Okay, we'll talk about this equation in a few minutes when it's necessary. So A for amount equals P for principal. What is the original value of this tennis bracelet? Times 1 plus, the reason I'm using 1 plus is because it's a growth. Alright, well what is the R value? What is the rate? 3%, but we want to write that as a decimal. Do 3 divided by 100. 0.03. 0.3 would have been 30%. And then raised to the T for time in years. Now, say you're taking a test and you don't see that as one of the answer choices. It may be because they simplified. You could really go ahead inside those parentheses and combine 1 plus 0.03 to 1.03. And that's the same thing. They just combined it. Okay, so now we're going to use that equation in question 2. What will the necklace be worth when you pass it on to your own daughter on her wedding day 25 years from now? So what do? Put 25 in. So it'll be $9,875 times 1.03 raised to the 25th power. Okay, what y'all get? .06, yeah. No, it went up. Wow. It was only that value when you received it. 25 years later, it would be appraised at this value.
Okay, Jordan.
Okay, number 3. You purchased a Dell laptop in 2007 for $689. Since technology is ever growing, your laptop depreciates 18% each year. Is this a growth or a decay? Decay. So we're going to be using the formula with the 1 minus R. Okay, well what is the original amount of the laptop? $689. times 1 minus 0.18, right, to the t power. Now, how else could I have written that equation? Right? What could you have rewritten that as?
Oh,
0.82. Okay, so that they want to know how much is your laptop now. So what would we do? The current year. What year is it? And when did we buy it? So how many years old is it? 9. So 689 times 0.82 to the 9th power. So how much is that laptop worth now? 115.49. So about $115.50 basically. Well, most people probably wouldn't even be using a laptop for 7 years, or 9 years, I mean. It's not going to be up to date.
unless it's sale.
Okay, next question. You recently opened a savings account with $4,500. The account is set up to earn you 5% annual interest. Find the account balance after 30 years if the interest is compounded annually. What does that mean, compounded annually? Right, once a year. So, A equals, what's the original amount you put in? Is this a growth or a decay? Growth. You're making money. So 1 plus what? 0.05, which really you could just rewrite as 1.05, raised to the what? What is the time? 30 years. Okay, so go and calculate that and you'll know how much is in that account after 30 years. Right, $19,448.74. Okay, look at the next one. The next one wants us to use this same scenario, but the interest is compounded continuously. Anytime you see that word, that's when you use that third formula. A equals P times E raised to the RT, per. So A equals, what goes in the P place? Right, 4,500. But then E raised to the R times T. Well, what is the rate? 0.05. And then times 30. Okay, let's talk about how to type this in. Alright, 4,500. Okay, look over here to the left of 4. Do you see that E above the LN button? So what do we need to press first? Second. And then since we have 2 things up there, what should we do? Parentheses. So 0.05 times 30 is for exponential. Okay, and then you get $20,167.60. Okay, I want you to take a few minutes and try 7 through 10 on your own.
Yeah, I did. Yeah.
Okay, check your answers. Oh. Alright, page 14. A scientist puts a single microorganism in a cultured broth. Every hour, the number of microorganisms doubles. T represents the number of hours. B of T represents the number of microorganisms after each hour. Is this a growth or a decay? Why? What word let you know that it doubles? So it's a growth. Okay. Now, think back to that original exponential function we learned the other day when we were graphing them. Y equals A times B to the X. Okay, watch. A equals, what is the principal amount? 1. You start with a single microorganism. Now, we're not going to have the need for 1 plus r, even though it's a growth. Because do we have a rate? A percentage? Well, but since it's not a percentage, all we have to write is 2 for doubles. And then raise it to the t powered. Now, they actually wanted you to write b of t instead of a, because they're using that for broth. Like, see how it's a culture broth? So they're saying the broth after t hours will equal blah, 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 whatever you get when you plug in t. Okay, so using the equation, how many microorganisms exist after 3.5 hours? So what would you do? Right, just 1 times 2 raised to the 3.5. No way. Correct. Okay, so now take like 30 seconds and plug in the other 3. What did you get after 8.5 hours?
128. Wait. Oh, I've got 3. Oh, 3.
Hold on, let me look at this.
Honestly, I don't know why you do like points. Yeah, this is messed up. You shouldn't even do point something.
362.04.
Oh, 3.
Okay, 7 hours, how many? And 12 hours. Right. Okay, we're going to skip number 2 for a second. Let's look at number 3. The value of an Accord bought new for $25,000 depreciates by 20% each year. So it is a decay because it's depreciating. And we have a percentage. So we're going to need to use that formula with 1 minus r. So A equals, what is the p-value? 1 minus 0.20, yeah. We skipped number 2. Raised to the t power. We already said this is a decay because it's depreciating. Shh. Now we're going to use this original equation that we created to determine the cost of the car after 1 year, 8 years, and 11.5 years. Okay, so plug in 1 for t and tell me how much the car would be worth. 20,000. Now plug in 8 and tell me how much the car would be worth. 4,000, what'd you say? 194.3, I know. And then 11.5 years. 1,920. You're right, that's what's up there. Did you type in 25,000? Shh, guys. Okay, if your car costs $8,200, approximately how many years old would you expect it to be? Okay, well let's use a little common sense here. After 1 year, your car dropped to 20,000. By the 8th year, it had dropped here. Well, if you want to find out how old it is when it's that much, isn't that in between those two? Aren't you just going to have to guess and check? Okay, Bryson says 3. Plug in 3. Everybody plug in. Okay, you plug in 4. Bryson plugs in 3. Somebody else plug in 5. Okay, what number was that? So 4 years is not enough, so go to 5 years.
Shut up.
Shh. And isn't that very close to 8,200? So 5 years. Okay, what is the inverse of an exponential function? No, we learned about them yesterday. The inverse of an exponential function. Logarithmic function. Next week, they didn't. Next week, we're going to learn how to convert an exponential to a logarithmic, and that way you don't have to just guess and check. You'll be able to solve it right away once it's a logarithmic function. Will the graph ever reach 0? No. There'll be an asymptote. Plus, even if your car is not even running, can't you get some money for it out of like scrap metal parts? Okay? All right, you need to do number 4 and after you do number 4, you can switch out.